Okay, so we're going to continue with naming ionic compounds, but now we're going to get into those transition metals that have multiple ions. So far we've only covered main group elements because they only contained one ion. And there's two systems for naming, two methods for naming metals with multiple ions. There's the classical system and the stock system. So honestly, the classical system is kind of dying out, and we're going to go ahead and help it die. We're not going to do that part. Okay, we're going to just cover the stock system, and it uses Roman numerals to indicate which ion is being used in the name. Okay, so for example here, if I have iron 2 plus, if I have that ion, then in the name I'm going to be putting 2 in Roman numerals in parentheses. So I know that that's the ion that was used. And if I have iron 3 plus, then I'm going to put 3 in parentheses in Roman numerals. So we're only going up to 4. So you won't use, you will use 1, 2, 3, and 4. And yeah, that should be it. Okay, so lead 2, again, we're putting 2 in parentheses. Lead 4, we're putting 4 in parentheses. Okay, so let's do some examples here. So what's the formula for copper 1 oxide? Okay, so first of all, the symbol for copper is Cu. Ugh, keep doing that. Sorry. Let's try that again. Here we go. Cu is the symbol for copper. And copper is one that has multiple ions, but I don't have to worry about which one it is because it's telling me right here it's copper 1. Okay, so copper plus 1. And then oxygen, the symbol is O, and the charge for oxygen is -2 because it's in group 6, so I'm going to put a -2 here. And then I'm going to do the whole switcheroo thing. So the 2 is going to go over here to copper. The 1's going to come over here. So I get Cu2O. Okay? So you have to be really careful here. So if I were to say name Cu2O, a lot of people kind of jump to, well, that's copper 2, right? Because there's a 2 next to it, but that's not what makes it copper 2. The charge from copper is over here, right? There's a 1 right there. So it's actually copper 1 oxide. So that can be tricky. You have to be careful with that. Okay, now we're going to do the name for Fe2O3. Okay, so Fe, the name is iron. So here's where we need to pay attention and see if we have multiple ions. So go back to that slide that had the periodic table with the charges. This is actually on your handout as well. You can see, there's a ton more elements with multiple ions, but these are the ones I'm going to test you over that are on that slide or on your handout, okay? So iron is one that has multiple ions, so I have to put in parentheses what the charge is. So remember, it's not the 2, right? The 2 came from oxygen, so it's actually the 3. So it's iron 3, so I'm going to put that in Roman numerals in parentheses, and then name the oxygen oxide. So that's why we don't put any prefixes in the names of the ionic compounds, is because we know the charges of the elements and we can figure out what the subscripts are. Okay, next one we have copper, which is Cu, right? So we're going to write copper. Okay, and again, copper is one with multiple ions, so we have to figure out what the charge is. You're always going to know the anion. So this is chlorine. Chlorine has a -1 charge because it's in group 7. So that 2 came from copper. So I'm going to put that in parentheses, copper 2, and then name chloride. Okay. Okay, now we're gonna name the next one. So we have SN. SN is the symbol for 10. So I'm gonna write 10. Okay, 10 does have multiple ions. So we know that chlorine is 1, a -1, so that 1 is right here. So that means the 4 belongs to 10. So we're going to put 4 in Roman numerals in parentheses and then name the chloride. So you'll never have parentheses on the nonmetal. Okay, it's always going to be parentheses with the Roman numeral on the metal, never on the nonmetal. Okay, and then again we have SN, which is 10. This one is tricky. Okay, so a lot of people will jump to, oh, okay, the 2 belongs to 10. But that's not the case, and here's why. So SN, let's use a different color. Okay, SN, we don't know the charge. Oxygen has a -2 charge, right? Because it's in group 6. So we know the 2 is going to come over here on SN, but there's not a 2 there. So what that means is it had to have been reduced. So they've used the empirical formula here. So the simplest whole number ratio was found. So that means the 2 was divided out. So if that's a 2 there, then there had to be a 4 here, right? Because when we divide by 2, we get SnO2. So that one is really tricky. So it's actually 10,4 oxide. So you have to be careful with that one. So that happens with tin and lead mostly. There are other ones that can happen with, but mostly what you'll see is tin and lead because they have that +4 ion. Okay, last one, titanium 4 oxide. I think going from the name to the formula is a whole lot easier. So titanium, the symbol is Ti. Okay, it has a +4 charge because it's in the name. And then oxygen has a -2 charge. So again, we're going to have to reduce it, Ti2O4, right? Because we have 2 coming over here, 4 coming over here. So I can't leave it TiO2. I have to divide by 2 and get TiO2. So those are tricky. You have to be careful. Okay, and then we also will be naming polyatomic ions. So remember I said you need to start memorizing those ones on your handout that are in bold. So here we have sulfite is SO3 -2. Sulfate is SO4 -2. But I want to give you maybe an easier way to memorize these. It may help, it may not. But look at bromate here. Okay, here's bromate. Bromate is BrO3 -1. Okay, now if I subtract an oxygen, O2, I get bromite, BrO2 -1. And that's the case for any of the polyatomic ions. Look up here at sulfate. Sulfate is SO4 -2. But if I subtract one oxygen, I get sulfite, which is SO3 -2. So I always tell people if you memorize the 8 ending for each of them, then you'll be able to figure out the other names. Okay, but you have to memorize the 8s for all of them because if you notice, they don't have the same number of oxygens, right? Bromate has 3 oxygens, sulfate has 4 oxygens. So you have to memorize the 8s. Or you can just memorize them flat out, however you want to do it. But I think that kind of helps. So going from 8 to ite, we just subtract an oxygen. Now going from ite to hypobromite, we subtract 1 more oxygen. Okay, so it's just BrO -1. Now going from bromate to perbromate, all I'm doing is adding 1 oxygen. So I get BrO4 -1. Okay, I can do the same thing for sulfate. So if I subtract an oxygen from sulfite and I get SO2, or I'm sorry, yeah, SO2 negative 2, then I would name that hyposulfite. Okay, and then if I added an oxygen to sulfate and got SO5 negative 2, I can call that persulfate. So that's why I think it's the easiest, is just to memorize the 8s for all of them. And then depending on if you're adding or subtracting oxygens, you can figure out the other names. So let's do these names here. So these are ionic compounds with polyatomic ions in them. Okay, so Na2, so Na is just sodium. Whoops. Sodium. And then SO4 is sulfate. So it's sodium sulfate. And that's it. So that's why it's so important for you to have the polyatomic ions memorized so that you can recognize them in the formula, right? You need to know that SO4 is sulfate. BrO4 is perbromate. SO3 is sulfite. Okay, if you can't recognize them in the formula, you won't be able to name them. Okay, so K is potassium. And then BrO4 is perbromate. Okay. Okay, and then we have FeSO3. So Fe is iron. Okay, and here you need to recognize iron is one of your metals that has multiple ions. So I'm going to have to put the charge in the name. Okay, potassium and sodium only have one ion, so I didn't need the Roman numerals. Okay, so SO3 has a -2 charge. Well, that -2 or that 2 is not showing up right here, right? And the 2 and nothing is over here for iron. So that means it had to have been reduced, and it was the empirical formula. So if there's no 2 right here, that means there had to be a 2 here. So iron is iron 2 sulfite. Okay, this one, hydrates, is actually not in your homework or your book, not until later, but I wanted to go ahead and mention it, the naming portion, so that when we do start using hydrates, you know what they are. But a hydrate is just an ionic compound that has water attached to it. That's all it is, okay? And we use Greek prefixes to indicate how many water molecules are attached to the ionic compound. So let's name the ionic compound first, right here. So Fe is iron, and iron has multiple ions, and we know the 3 goes to iron because 1 is for chlorine. So iron 3 chloride, oh, there's a bad parentheses. There we go. Chloride is the name of the ionic compound, okay? And then we have 6 waters, okay? But we're not going to say 6 waters. We're going to use the prefix for 6, which is hexa. And we're going to say hydrate instead of water. So we're going to say iron 3 chloride hexa. And it should be one word, but I'm out of room. Hydrate. Okay, hexahydrate. So that dot right here shows, sorry, good grief. Okay, let's try this again. Okay, the dot right here shows that the waters are attached to the ionic compound. So that's how you know it's a hydrate. Okay, so iron 3 chloride hexahydrate, and then the next one, we have Ba, which is barium. Okay, barium only has one ion because it's in group 1. And then Cl is chloride. Okay, and then we have 2 waters, so it's going to be dihydrate. Okay, so that's it. So you just name the ionic compound, and then you name how many waters you have using the Greek prefix anhydrate. Okay, next what I want you to do is take out that same worksheet that we've been using, and I want you to work on numbers 21 through 40. So that's the last of the ionic compounds, and that contains every rule that we've talked about, okay? So be careful. Make sure if your metal has multiple ions, you put the Roman numeral in parentheses next to the metal's name. And if it doesn't have multiple ions, then make sure not to put Roman numerals, okay? So there's some in there that don't have multiple ions. And I want to show you this real quick. Let's see if I can go back. Maybe I can figure it out. There we go. Let me go back to this right here. Okay, so not all the transition metals have multiple ions. If you'll notice right here, zinc, cadmium, and silver, they only have one ion. So you're not going to put Roman numerals with those three. Okay, so zinc is in here quite a few times. I think I have silver, yep, is there. I'm not sure about cadmium. So be careful, because those three won't need Roman numerals, okay? So make sure you have your handout out while you're doing this, so you can see which metals have multiple ions, and that will kind of help you out. So make sure to do 21 through 40 before you move on, because again, we have one more set of rules to learn for acids, and if you're not working on these and getting them down before you move on to the next portion, it gets really difficult.